Thank you. First of all, before even starting, I need to say that I'm really happy to be here on this stage because my adventure with functional programming communities and open source and all this cool stuff has started a couple of years ago on this conference. So I'm really happy to be back here, this time on this side of the stage. And yeah, my name is Chris. I'm doing quite a lot of F# open source stuff. I'm doing quite a lot of photography, and I'm annoyingly vocal on Twitter about things like open source sustainability. So yeah, what I'm going to talk about today. First of all, I'll talk a bit about compiler design. We won't go much into any technical details. This will be just high-level overview. Then I'll talk about concept of compiler as a service. Then I'll mention a few things about language server protocol and about user experience, because that's obviously what we want to talk on functional programming conference. And at the end, well, maybe not at the end, but I will also mention a bit about F# tooling architecture. So even though this talk has F# in the title, and a lot of examples that I will be using that are based on F#, it's kind of, I would hope that some of the stuff that I'll be talking about is applicable also to other languages, hopefully to other functional programming languages. And hopefully we can all learn from each other to do some cool stuff. And there's a couple of shortcuts that may happen, that might be shown on the slides, or I may mention some of those. So let's start with F#. F#, for those of you who don't know, is a functional first programming language from Microsoft running on .NET platform. .NET is nowadays, with .NET Core, it's open source, it's cross-platform, so it's running everywhere. I usually develop stuff on my MacBook Pro. Then there is something called Visual Studio. Visual Studio is IDE from Microsoft for Windows. And then there is something called Visual Studio Code, which is this really super cool editor that Microsoft created. And that's probably the first product of Microsoft that everyone loves. So Microsoft is really happy about creating Visual Studio Code. It's cross-platform. It lies somewhere in between of text editors and IDEs. It can definitely, with right plugins, it can be transformed into really powerful IDE. Yeah. Then there is something called FCS. This is F# compiler service. And I will go into details a bit later. It's just if those happen to be on the slides, so you kind of know what those shortcuts represent. And then there is FS autocomplete, FSAC, which is language server for F#. And then there is two types of abstract syntax tree that I may mention somewhere in this talk. So let's start with compiler design. So if any of you created their own compiler, or if any of you were at university, had a course in creating compilers, you probably know that traditionally compilers look more or less like that. There is a couple of phases. It might differ from language to language because a lot of stuff depends on language design. But in principle, it's almost always it's a pipeline of steps that you perform one after another. And usually this whole thing is kind of treated as some magical black box. You put files into that, then magic happens. You wait for a couple of minutes. If you're using Scala, then a couple of hours. And then you get back the some object file or executable file or DLL or whatever your platform produces. On the other hand, we have modern editor tooling like Visual Studio with C#, like JetBrains with Java, or any other mainstream editor tooling. And this editor tooling has a couple of features. First of all, it's rich. You can do really lot of stuff with modern editor tooling. Not only simple tooltips and autocomplete, but all different kinds of code analyzing, all different kinds of refactoring, and so on. Secondly, hopefully it's unintrusive, so it doesn't interrupt your flow. As you know, as developers, we want to be in this flow state of mind where we're just coding and nothing stops us from creating something cool, to using power of our mind to do magic, and then someone comes to us and says, oh, do you have a moment? And everything goes down from that point of time. So hopefully our editor tooling is not this your random coworker that just stops you from focusing. Hopefully it provides you help instead of interrupting you. Thirdly, hopefully, again, it's correct. As in, if you get red squiggles and errors in editor, you kind of expect that those are the same errors that you would get from compiling your application from command line, unless you are a Scala developer using JetBrains Scala plugin, and then you expect something else. I really like Scala. By the way, I'm joking about Scala a lot, but I really, really like Scala. Please don't take that as some hate on Scala. Next, it needs to be context aware. So hopefully, again, it provides you information that you need in this particular moment of time, in this particular part of code, not something totally random. Like, for example, in Visual Studio, there is this object explorer thing that shows you totally random stuff that is totally not connected with the things that you code. Responsive and performant. And those are two different things, because responsiveness is a performance that's actually perceived by the users. It doesn't necessarily mean being responsive doesn't necessarily mean that actually everything is happening fast or everything is optimized. It just means that user thinks that things are happening fast. And this is really important because we can use a lot of weird tricks to convince user that things are happening fast while they're not happening fast. So this compiler 101, this black box design of the compilers traditional that we learn from books at the university, is not really good enough to implement rich editor tooling. And this is not something new. This is not a new idea. It has been around for years. But usually it meant that your tooling was tightly coupled with the compiler. That happened in like Borland, Delphi times, if you remember that, or maybe Smalltalk times, if you remember that, even before Borland stuff. So compiler to provide enough functionality for those features, compiler needs to be not just command line utility that just runs once and forgets about code, does some magic inside. It needs to be server, so a long running process. It needs to be an API, so something that you can somehow call, that provides you with some functionalities that you can use. And it needs also to be database of the stuff that compiler knows. Our compilers, especially in typed languages, knows really a lot about code, our code. They know about types of given symbols and all the stuff about relationship between files, a relationship between symbols, between symbol and symbol uses, and so on, so on, so on. So you need to have some kind of API to query that. And this obviously heavily impacts the design of the compiler, because it's totally, I think we all know that, it's totally something different to create run once and forgot CLI tool, command line interface tool, and it's something totally different to implement long running process. It has impact on the performance, it has impact of the memory usage, it has impact on general architecture of how your program is structured. And in case of F#, there is this project called F# Compiler Service. It's a version of F# compiler that provides additional APIs to the compiler. So F# compiler is written in F#, because that's what all cool languages do nowadays. I mean, they're bootstrapping itself, like C# compiler is written in C#, Java compiler is written in Java, and so on, so on, so on. So because it's written in F#, it can be treated as a normal .NET library. So it means that you can just add it to your project and use it. But that part is not enough. So F# compiler services is also adding a bunch of additional APIs to the compiler. And those are those red boxes. And again, this is really high-level overview, so it's not going too much into details because that would be really F# specific, and it's not really goal of this talk to be so F# specific. So there is Lexer API, there is something called Abstract Syntax Tree API, and there is like some additional editor services and some additional ability to query the known symbols in that compiler knows. And what is important is that you can call those services like independently from each other. You don't need to run through whole cycle of the compiler. You can just say, oh, let's type check this file, this particular file, or let's parse this particular part of the file, or let's lex this line of code. And you can use results to provide rich editor experience for that. So first one I would like to mention is this Abstract Syntax Tree API. Abstract Syntax Tree is implemented in F# as a whole bunch of discriminated unions, so union type, which means that working with Abstract Syntax Tree is a lot of pattern matching. Basically, it's like thousands of lines of code of pattern matching when you want to traverse Abstract Syntax Tree and you want to learn something interesting from that. And Abstract Syntax Tree is usually used for the features that describes that are handling somehow structure of your code. So for example, if you want to put in Visual Studio Code, there's this feature of code lenses. So there's this small additional text that editor can insert on top of your, for example, function, that you can put some content there. So for example, for finding places where you should put those, where your functions are defined, where your like top-level functions, for example, are defined, or top-level types are defined, finding those places, Abstract Syntax Tree API is used for that. It's used for formatting also, with a bunch of other hacks that Jindřich can tell you more about because he knows about this stuff. On the other hand, we also have something called Editor Service API, and this is built-in low-level editor functionalities. And by low level, I mean, it's really usable, and for many languages this would be good enough, but in F# we tend to strive for a bit more advanced features usually. So for example, Editor Service API has a function called getTooltip@position. You give position, it returns you content of the tooltip. It's base for many editor features, autocomplete, tooltips, go to symbol definition, find all references, and all those features that we know from mainstream languages with powerful IDs. They can be implemented with Editor Service API, but we usually want to add some additional stuff on top of that. And there's also Symbol API that's using typed Abstract Syntax Tree and type checking results. And this API provides you rich information about given symbol from your code. So for example, you define function and you want to know what's the type of this function, what it returns, what is the number of arguments, what are the types of the arguments, what attributes have you put on top of that, and so on. So this is really useful. The problem is that this layer, and actually this layer also, they need type checking results. And type checking is expensive process in basically any programming language. Sorry. And as I've mentioned, the really cool thing, and again, this stuff, this is nothing really new. This is not really something super specific to F#. But what is really cool is that F# compiler service is distributed as normal .NET library. That means that you can add it to your project and you can create your own tooling for the language. And this brings us to idea of ubiquitous language tooling, which is really strongly, so this term is really often used by F# team in Microsoft. And the basic idea is let's say this. So you have F# compiler as a lowest level. Then you have F# compiler services, that's kind of like version of F# compiler. And then all other possible tools that are providing editor tooling or any other kind of tooling for F# are using this common base of features. That means they don't need to re-implement their stuff on their own. That means that when you do autocomplete request in Visual Studio and you will do autocomplete request in JetBrains Rider, you will get the same result, the same list of the results, because they are provided by the same base functionality, base library. And this is really nice because it means that, yeah, we have this one basic layer that we can all contribute to, making everyone's life better. And that means that switching between editors is not so problematic. And it also means that we, as a community, we are not buying into single editor. We are not telling people, oh, you should just use Visual Studio, because maybe you prefer use JetBrains Rider, or maybe you prefer use Visual Studio Code with Ionite. And then you should have really similar level of editor tooling. There are some different details between those, but basic level should be really the same. So now I would like to talk a bit about a project called FS Autocomplete, and this is a project that I happen to maintain from time to time. It's community-driven open source projects. So unlike Visual Studio or Visual Studio for Mac or Rider, those are projects developed by powerful corporations, rich corporations that have a lot of developers. FS Autocomplete is a community-driven tool. It's open source project that's couple years old, like 8 or 7 years old, something like that. It actually has started before I was even doing F#. It is language server for F#, so the whole concept of language server, maybe let's start with that. The F# compiler service is a .NET library, so you can use it easily from the .NET processes. So you can easily use it from Visual Studio. Visual Studio has running .NET under the hood, has its own host. You can easily use it from Visual Studio for Mac because it's also using .NET under the hood. You can easily use it from Rider because, well, Rider is Java. Front end of Rider is in Java, but backend is also written in .NET. So they can those three projects can just add F# compiler services at normal reference to their project. Okay, and they have the API. However, Visual Studio Code is an Electron application. It means it's written in JavaScript, and it's also using JavaScript for extensions. Emacs is using lovely Emacs Lisp. Vim is using something. And so on. So those different editors, different tools, they may not necessarily be able to just add reference to your normal .NET library, because obviously you cannot add in your JavaScript extension for Visual Studio Code, you cannot just add .NET library and communicate and call APIs. So the concept of language server is the idea of putting the layer between this normal .NET library and your other editors that will provide some common communication protocol. There used to be a couple of implementations for FS Autocomplete. First one was using standard input-output using some custom protocol, and you were just sending messages by writing to the standard input and getting responses from the standard output. Then we've added HTTP protocol mostly because I've started working with Visual Studio Code and with Atom before that, and those are JavaScript. As I've mentioned, JavaScript applications, so calling HTTP from JavaScript is really easy. So HTTP and JSON was really easy way of communicating. Nowadays, it's using something called language server protocol, and I will describe that a bit later. It provides high-level API. So the goal is that you call FS Autocomplete, you get result, and you don't need to do anything else. What you need to do as a vendor of editor plugin is to put that on the screen somehow. It depends on editor how, but that's not really the topic here. And yes, nowadays it's using language server protocol, and shout outs to Microsoft because Microsoft sponsored work on that part of the FS Autocomplete by hiring me for a couple of months. So yeah, editor tooling is kind of complex. As I've mentioned, we have this F# language service, and F# language service is used not only by FS Autocomplete directly, but it's also used by a couple of other projects. For example, F# linter, which is a project that's adding a bunch of additional linting analyzers tools to the language. It's used by Fantomas, which is F# code formatter. It's used by a project called F# analyzers that's giving users ability to write their own editor tools and their own editor warnings and their own code refactorings. It's a really cool tool. So we have this FS Autocomplete, and everything is coming to this one point. We also have something called FS Autocomplete background service, and this is the part where I've mentioned before when we kind of trick users to believing into tooling being performant, but rather we focus on tooling being responsive. So background service is another process that do a lot of stuff, a lot of processing in the background. It's putting some of the data into SQLite database on the disk to make sure that everything is working a bit better. And then, on the other hand, we have editor plugin. And editor plugin can communicate with FS Autocomplete, but editor plugins are also responsible for a whole bunch of other stuff regarding more general user experience, such as communicating with fake, which is F# make fake. Yay. Yeah, F# community is really great at names, trust me. Just take existing name, put F as a first letter, and yay. It also communicates with F# interactive, which is REPL, F# REPL. It also, editor plugin may be responsible for communicating with MS Build or .NET, which are like .NET tools. It may be responsible for communicating with debugger, or with something called Packet, which is package manager for F#. So this is general overview. The interesting part is this arrow, this communication between FS Autocomplete and editor plugin. So a couple of years ago, Microsoft came up with this initiative called Language Server Protocol. And the goal is to provide common communication protocol for the editor tools to use. So, do I have the slide? No, I don't. So, in the past, every language, as I've mentioned, idea of language server is not new. It's not really connected to language server protocol. So, in the past, every language implemented its own language server with its own protocol. Then people had to create editor plugins for every editor they wanted. So it was kind of n times m problem in terms of if you had n languages and m editors. There was like a lot of different possibilities, different connections. And language server protocol is putting in the middle common communication layer. So now as a vendor of editor plugin, I just implement Vim plugin or Emacs plugin or Visual Studio Code plugin that is communicating with language server protocol with any backend using language server protocol. And as a vendor of backend of the tooling of the language server, I just tell, okay, I'm implementing language server protocol, so I don't need to come up with my own protocol. I just do that, and hopefully this means that my language server will work across many different editors. This is working more or less in practice. So Visual Studio Code is best implementation on the client because that's what Microsoft maintains, and that's the kind of go-to implementation when you want to look at what is possible with language server protocol. And the other implementations like for Vim or Emacs are maintained by the community. And they're pretty good. I mean, people are using them, they're happy with them, and everything is fine. However, language server protocol is, again, this common level. It kind of takes this common level that Microsoft thinks all the tools, and I'm saying that is Microsoft, but in the end, language server protocol is open source project. It's adapted by community. It's adapted by multiple different vendors than Microsoft. It's not just Microsoft per se deciding what's in language server protocol. there's like whole community discussing this stuff, and there's like whole bunch of vendors, Eclipse Chair, and others that are using that for also commercial purposes. So it's not just Microsoft do something. But still, it is kind of common, this common point, and this may not be good enough for every tooling. Like every languages has differences, obviously, and this means that maybe sometimes for language X, for F#, you need a bunch of different tools than for C# or for Haskell. So language server protocol also enables you to expand the protocol. So if you're creating server, you're just saying that, oh, we've implemented this whole bunch of the language server protocol specification endpoints, but we can also say, oh, I've implemented those additional endpoints. Feel free to use them in your editor. This means that as a vendor for editor plugin, probably you need to also code something on editor side, because this like common Vim LSP plugin, it doesn't have knowledge about those additional stuff, but usually those plugins also enables you to implement your own custom extensions. So for example, in case of F#, there's a couple of those extensions. We have something called Solution Explorer, because Microsoft has this genius format of solution files and project files and all this really easily understandable stuff. So we have this additional panel in Visual Studio Code where you can explore your project, your solution, and sorry for the quality of the. Sorry about that. So for example, it can list what are the references of your project, what are the files in your project, and so on, so on, so on. And this is especially in case of F#, this is really important because, for example, F# compiler is single pass compiler, which means the order of the files in the project file matters because it doesn't do multiple runs over your code. So you need to give files in correct order for the program to compile. So for example, there are like buttons to move file up, move file down, and things like that. There's a couple of other features that are F# specific. There's a whole bunch of integration with .NET tooling that we have in FS Autocomplete as those custom extensions. Really something nicely that we do is we have this concept of the line lenses. So F# has really powerful global type inference. Which means that very often you are able to just don't specify types and the compiler will figure out what is the type of given expression. But this is sometimes it's really kind of hard to read. It's really nice when you write this code and you're like, okay, I know what's going on, but after you come up to after 5 months to the code base, it's kind of a bit difficult sometimes to read what's going on. So we have this concept called line lenses that's putting the inferred type of your statement as a virtual comment after the statement. So for example, you have let e equals 1, and it will put at the end of the line the int, the fact that this is integer. So this is really nice, really productive addition to the tooling. Another really cool stuff is this info panel, and this is attempt to kind of improve the tooltip and autocomplete experience. Because really often when you write code and you want to get tooltip on something, you need to get mouse, you need to put cursor on top of that symbol, and then there will be some pop-up and you will read. And info panel is attempting to provide the same information but in a separate panel that's kind of next to your code. And when you write something and you move cursor with your keyboard, it's kind of update. And it displays whole documentation that we know about given symbol or given type and so on, so on, so on. Okay. Another thing I would like to mention about F# tooling is this project called F# Analyzers. And F# Analyzers is a project inspired by Roslyn Analyzers, if you're familiar with C# tooling. And it basically enables you to write as a developer your custom analyzers for the code and provide custom error messages or warning messages or code refactorings in your editor. And those analyzers are distributed as a normal packages that kind of we just detect. There is analyzer package. You've added to your project analyzer package, and we want to do some cool stuff. So for example, again, sorry for the quality of that. Here on the right side, this is an example of the analyzer that detects using of option.value call. So F# has built-in option type, so you can write some, one, or none. But if you write let x equals none, then nothing stops you from writing x.value. For reasons unknown to me, there is quite a lot of those functions that can just crash on the runtime in F#. For example, there is head function on the list, which crashes when you use it on the empty list because empty list doesn't have head, and things like that. So, for example, you can write analyzers to detect those function calls and say, oh, maybe you shouldn't use those functions. Maybe it's not the best idea. And this, sorry again, for if anyone is interested, I can show demo later. This is really interesting example. This is re-implementation of typed calls from Haskell or from PureScript in using F# analyzers. So this is, and you need to believe me because I almost cannot see that, so I don't believe anyone can see that. This is, I have a list from 1 to 10, then I'm doing some mapping on the list, then I have something called whole, and then I have another list then another function that operates on the list. And then this whole tells my analyzer, hey, I don't know what is this thing that I want to put here. And then using type inference, we infer that this whole have type from list of integers to list of integers or something like that based on the context of whole expression. And then we go through all known symbols to the compiler at that point and find those symbols that are fitting this particular definition. So for example, it can say that, oh, replace this whole with program mymap, which is defined here as an example. This is something that's built in the Haskell compiler and in PureScript compiler. And obviously in Haskell and PureScript, this is really way more powerful thanks to the type classes. But I think this is really also pretty useful for F#. And this is not production ready. It's something that I've implemented as a demo to show people how many cool stuff you can do with analyzers. But I hope that maybe one day someone will pick it up, or maybe I will find a bit more time to work on that. And now let's talk about developer experience, because we've talked a bit about architecture, about like some small technical details. But to be fair, the most important thing about editor tooling, about developer tooling, is your user experience, because what we need is actually to make you happy as a tooling vendors. And again, this fancy list of the features. And what is important is that building tooling is an art of the balance, because the richer your tooling is, the more features it provides, the more powerful it is, the bigger performance problem it has. It's pretty obvious. It's something that's really hard to work around, especially given that most languages, most compilers are like single-threaded, especially in context of F#, because F# has this type inference again. The type inference algorithms are kind of like single-threaded by design. Well, there's one white paper showing parallel type checking, but yeah, that's not really production ready. So building tooling is an art of the balance. You need to choose what you want to provide when you put some kind of, okay, I don't want to provide more features because it will make lives of my users worse. Or rather, it's about finding good default settings. So everyone has their preferred workflow. This is what I've learned during those couple of years of building editor tooling is that there always will be this one person that will come to me and say, oh, but if that worked like that and that and that, and that's my magical way of doing things, yeah, sure, good for you. Unfortunately, you need, as a vendor of the tooling, you need to be able to find some kind of balance between all those things that I've mentioned before, and you need to also find balance between saying yes to the request from the users. So my biggest mistake that I've made during those couple of years is that I've way too often said yes to the feature request. And it's really something hard to learn, because sometimes people are really like emotional about the stuff they want. Sometimes they're really invested, so there are a lot of people that kind of, okay, I will send you pull request with this my preferred workflow, and they've done it, but maybe it doesn't mean that it should be merged to their project. It's really, if that doesn't fit with general design of the tool, maybe it would be a better idea to just say no. So yes, focusing on finding good defaults. Also, we need to, as developers of editor toolings, we need to focus on getting started experience, and tools hopefully should just work. This is like this famous Microsoft thingy of you install it and it just works. Because users don't read READMEs, users don't read documentation. Other thing is that often the tools doesn't have good documentation. That's the other thing. But even if they sometimes have good documentation, users just expect stuff to work. So getting started experience is just really, really important. And another thing I've learned over those couple of years is that user experience is way more important than technical perfection of your tool. So I prefer to sacrifice some performance, for example, for better user experience. I prefer to, well, correctness maybe not, but in general, I will not add some super powerful, rich feature if it would be really difficult to use, if it would be not discoverable, and so on, so on, so on. This is maybe a bit more general, open source or general building software advice. There is enormous value in short feedback loop. So just release stuff to your users, and then they will complain, and then you will fix problems. Especially in something as focused on user experience as a developer tooling. This is really important. In the peak of working on FS Autocomplete and Ionite, we've been releasing basically one version per day of the tool. Nowadays I fixed most problems, so we don't release so often. But yeah, definitely the value of short feedback loop is enormous, and I strongly recommend if you build any open source project. And I'm not saying that release this as a production ready version, but maybe have some concept of betas or release candidates and some mechanism of distribution those. That really depends on the platform that you develop for. Another important thing that's kind of more tooling related is that tooling is an abstraction layer. It's using all those stuff that I've mentioned under the hood. When you're opening your editor, there is a whole bunch of stuff happening like that you don't realize. There is like project parsing, there is like compiler starting in the background, there is like some additional processes, and all this difficult stuff that's going on. And you should make sure that those problems doesn't really leak too often, or if they leak with some nice error messages that actually are useful for the people. Again, this is something that I've learned from a lot of mistakes. I've made a lot of mistakes over those last couple of years. So yeah, making good error messages, and especially error messages that kind of suggest also what's wrong. Hey, we cannot do something. What about setting this setting to some path to something? Yeah, that's really useful for users, because they have at least this first step of oh, maybe let's try something different. Or maybe it's just pushing them in the right direction. Oh, there are some settings in this tool. I didn't know about that. That happens. So yeah. At the end, building tooling is fun. You should try it out. You should contribute to your favorite editor or favorite favorite language server in your favorite language. There is a lot of really exciting stuff happening in the functional programming, in the tooling space. So in F# there is a lot of need for more contributors to either Visual Studio tooling, because it's open source, or FS Autocomplete, or Rider, because that's also Rider F# plugin is also open source. But also in other ecosystems. In Haskell recently they've made this decision to merge Haskell IDE engine with the GHC IDE. That were two major tooling vendors, and it's really, really cool that people are working on that actively. And I think that, yeah, that would be it. What I've talked about. I've talked about a bit about compiler. I've talked about compiler as a service, so this idea of providing compiler as a normal package that you can use with additional APIs. I've mentioned briefly language server protocol. I really quickly mentioned some stuff about user experience, and please do focus on user experience. Whenever you do any software, please do focus on user experience and F# tooling. Are there any questions? Yeah, there are some. Yeah. How much time do we have actually?
We can have 2 questions.
Yeah, thanks. Awesome.
Thank you. Do you think the language server protocol is a finished product, or will you be, or is there new features coming in, like the one you showed, putting the infer type in a command? That's very cool. Can you get that in that? Yeah.
So language server protocol is actively developed. I think right now there's version 3 point something, 3.5 or something. It's actively developed. Yeah, there are people working on that. Its development is a bit of coupled with the development of Visual Studio Code. So fairly often it turns out that when Microsoft needs a new feature in Visual Studio Code, especially for TypeScript or JavaScript, they will add new stuff to the language server protocol. But there are also people from other vendors from the community that are driving forward new features into language server protocol. So it's whole time underdeveloped. It's not like set in stone and we won't touch that. It's actively developed.
Okay, so question, how hard would it be to write a custom analyzer for your project? Let's say that you have some method or class that is like fragile or is contacting some fragile service, and you want to provide some maybe custom annotation for that particular method, and then to display the warning everywhere where this method is used, right? So that will be some custom feature for your particular product. Is it like possible to do that with minimal effort, or?
Yes. Yeah. So the effort to do that is pretty minimal. So what you need to do is kind of you just take care about logic. So as an input for F#, basically implementation of F# analyzer is single function. It takes in as an input context, something I call context, and context contains abstract syntax tree, typed abstract syntax tree, and a symbol database that you can query, and some other stuff. And then it returns list of warnings with potential code fixes. So what you need to do is, if you want to detect some kind of method that you don't want to use in your code base, you just traverse the abstract syntax tree using pattern matching, and then when you find this occurrence of this method, you add that result, and then you return that from your function. Then we, in the tooling, in FS Autocomplete, we load this analyzer in memory, and then we just run it for every time we type check file, we run this analyzer. And then if any errors were returned, then we will propagate that to the editor. But that's not something you need to take care about as a developer. As a developer, you only need to take care about the core logic of your analyzer. That's kind of the design goal behind the project.
All right. Thanks, Krzysztof.
Thank you. So, yeah, again, my name is Krzysztof. You can find me on Twitter, you can email me, you can find me on GitHub, on 500px if you are into photography, on Goodreads if you're into reading books. I have consulting company if you'd be interested in some F# stuff. And you can also support development of Ionide and in general community-driven F# open source tooling on Open Collective. Thank you.